Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue talking about our direct access binary files, and we're going to talk about fixed record length files. So this is when we have a file that we can do direct access on, but all of the records in it have the same length. And it turns out that makes our lives a lot simpler. So in the last video we wrote this class for a particle, and it has methods to write and read things. This is a perfect example of a fixed record length file. Every record in here has the same length, and indeed we even calculated this. In fact, we could call this record length if we want to use a different name. So every particle takes the same number of bytes in the file. So what I'd like to do is, in our ADTs, I want to create a new class for a fixed record length file. And our fixed record length file, when we create it, we're going to pass it two pieces of information. The name of the file that we want it to be attached to, and a record length. Okay. We'll find out that we need some more information in just a bit, but this is sufficient for now. Also, because this is a collection, we're going to make it so that it takes a type parameter A, and that is the type of the records that we're storing in here. And I would like to have this so that it extends a mutable indexed sequence. You should probably go look at that in the API to make sure that you understand what this is. So an index sequence is a sequence that you have the ability to efficiently get values at particular indices. And we're making our version mutable, which only makes sense for a file. Whereas immutable collections in memory, where you effectively make a copy or a partial copy every time you change things, those can be very helpful in memory. You don't want to have to make a new file, or in the idea of a partial new file doesn't even make sense if we're going to store these things inside of a file. There are three abstract methods that we have to write: apply, length, and update. And so our bar is fairly low here for creating one of these. So I want to make this a mutable indexed sequence of A, and I will import collection mutable. And now this is unhappy because we don't have the methods that we promised we would give it. So I will go ahead and copy things out of the API here. We have our apply method. We have our length method, and I'll give that a 0 for right now. And we have our update method. Change the formatting up so this doesn't look quite so ugly. And now the main problem that we have is our apply. It says it's going to return something, and it doesn't. Okay. When we create one of these, we inevitably need to make it attached to the file. So we will make a random access file. That connects to that file name, and we're going to make it so that it has the ability to both read and write. We need to import. Oh, and I need the keyword new to make that. Okay. Now we need to write these methods. In some ways, length is the one that I guess we could write most easily at this point. Our random access file actually has the ability to tell us a length. Right here tells us how long the file is. So our current collection would then have a length that is random access file length divided by record length. It's unhappy because technically that returns a long. We just need to convert this to an int to make that happen. Okay. What about apply and update? So apply is supposed to look up a value in this file. The first part of that isn't too hard to do. We need to move to the right location in the file. And we do that with the seek method. And the question is, well, where should we go? And this is the advantage of this being a fixed record length. Okay? The file is set up so, for example, if the record linked with 10, the first record would take the first 10 bytes, and the next record would take the next 10 bytes, the next record would take the next 10 bytes. So whatever index I'm looking for, I simply want to jump to that times my record length, and that puts me at the correct location in the file. Okay. Now I need to read it, and this is potentially more problematic. Okay. How do we read the value from the file? Because we don't even know what the type is. We know we're reading some type A, but at this point in the code, A could be anything. Turns out this is something that's going to have to be provided to us by the user. Okay, so we're going to need to pass in another argument here. This other argument, maybe we could call it the reader, is going to be a function that takes a, well, it doesn't have to necessarily be a random access file, it just needs to be a data input, which has all of the read methods that we want. And I import the data input, and then, that's interesting highlighting there, and it needs to return to us something of type A. So the outside code knows what the type A is, and it has the ability to provide us with a function that takes a data input and gives us back something of type A. So if we had that, we could simply call reader on the random access file, and that, I'm just going to be happier if I put some parentheses. I have no idea why the syntax highlighting is turning that color. Interesting. Well, we'll see if it resolves in just a bit here. So it turns out the apply method is really just that simple. We seek to the right location of the file, and then we use the reader that the outside code provided to us in order to read in the element. What about for update? Well, we're going to start off the same way. We need to jump to the same location in the file, but then we need to write out this element at that location. Just like with the reader, this is something that we really don't know how to do with type A, so I'm going to create a writer, which also takes a data input, or sorry, in this case it's not a data input, it's a data output. In addition to the data output, it takes an object of type A, and it returns unit. Okay, we don't need anything from it. We import that. The importing, for some reason, does that weird color changing, and since my cursor was on unit, that's where it hit. So this writer, we pass it 2 arguments, and it doesn't give us back anything, and since update doesn't give us back anything, that's just fine. We call writer on the random access file and pass it the elem. So all that this is really doing is making sure that we seek to the right locations. These methods are remarkably simple. How could we utilize this? Well, we have this particle type here, and so it would be interesting to possibly write a little code just to make sure that we understand how this works. So we're going to put a main inside of here, and I want to make a new fixed record length file The file name I'm going to use is particles.bin, and the second argument we have is our record length. Well, our record length was stored, actually I should make this so it's not inside of the particle, it's inside of the companion object so that I can get hold of it. Particle dot record length, we will have to import this is under extras, except I'm going to want to use that more, and in fact we're going to need it right here because this needs a type. Is that enough to help it find it? Yeah. Okay, so it found extras.particle, and now we need two other arguments. The first one is a function for reading these. Well, so I'm going to pass in a function that takes a random access file. Actually, no, we'll just make it a data input. And I want to call particle on that data input, because we have reading code inside of our particles companion object. Similarly, if I want a function that writes this out, it's supposed to take a data output. How about I call this because do is keyword for our do while loop of the data output and a particle p, and I want to call p dot write to file of data out. Okay. That's all we need to create one of these. File name, record length, a function to read data in, and a function to read data out, and then we have the ability to store things in there. Now it's interesting to note at this point that the way I've created this, the length starts off at 0. Now with most of your indexed sequences, that would be very problematic for us, because then if you have something of size 0, you can't store anything in it. But the way that the random access file works, when you call seek, so if we go and we look at seek, it turns out that you can actually seek beyond the end of the file, and then when you write to it, it will be there and it will create the data that you want and put it way down at the end. So we're actually allowed to do updates beyond the index using what we've written here. That doesn't necessarily adhere to the normal interface for an index sequence, but we're perfectly happy that it does it for our purposes here. So I can take the fixed record length file sub 0 equals a new particle that looks like the particle we did last time, and then we can put something at index 1, give it a different index, a different mass. There we go. So we have a completely different particle there. One thing that's not happening that I would actually like to do is just explicitly put in a close method. So that when we are done with this, we have the ability to close it off. This read things in. We could also val p1 equals fixed record length file sub 0 of p1.x dot y, p1 dot z, p1 dot mass, p1 dot id. Actually, instead of doing it that way, how about we do this? What was I doing there? For P1 in okay, so we have the output here, and we've noticed that this worked with our standard for loop, and it ran through and pulled out each of these values. One thing to note about this, because we haven't made this so that it works, quite completely with all of the methods of an index sequence, and in fact, in some ways we don't want to. If we were to call map on this, I don't know exactly what we want. Moved equals dot map. Let's say t bucket p dot x equals 8. Not something I'd actually do. I'd actually want to update things by the velocities, but I'm going to type in this line simply because I want you to see the return type here. Okay, the return type is not I don't have an easy way to change things. Well, we'll just make it the identity, in which case map would do a copy. Notice this gives us back a mutable index sequence, which the fixed record length file is, but the one it gives us back is going to exist in memory. And this makes sense simply because if we were going to map this to a new fixed record length file, we would have needed an alternate file name, which we can't put inside of the map method. So these things, when you call map, filter, or any of the functional methods on here that make a new collection for you, they're going to wind up giving you back a memory-based collection in its place, and that's perfectly fine for us. So that's it for this video. In the next video, we'll come back and we'll talk about variable length record files.